Hello everyone, this is the lecture for section 3.5, dividing polynomials. So for the next couple of sections, and we've sort of seen this in the previous couple of sections, and in particular 3.3 and 3.4, nice things can be seen in our graph if we have it in our factored form. If we have something, I'm going to write it right here. F of x is equal to something times something times something times something, right? And this is usually like an x minus, blah, 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 x plus something, right? An x minus something, and then another x minus something, right? And we have power. So this can be cubed, this can be to the fourth, this can be third, right? And this last one can be whatever it wants to be. Let's leave it like that, right? If we have it in this method, right? If we have it in this version, we can see just from the function where our x-intercepts are going to be, right? Okay, and we've seen sort of the connection between the two, right? So if you see it this way, if you see our function, our polynomial function sort of in this manner, right, then automatically we get a lot of good information from it, right? Okay? But at the moment, we've only gotten up to, how can I say it? I've given you something like this, right? I've given you something in this method, in this version, and you know now what it's supposed to do in the graph, right? Okay. We are getting closer and closer to being able to do, receive, right, or look at functions, polynomial functions, in the expanded version, right, and turn them into this right here. So that's what we're going toward. That's the direction we're heading toward now. That I'm going to be able to give you, right, a polynomial function, and for the most part, right, without going, without getting, giving you something way too massive, right, be able to turn it into this right here, turn it into the factored form. Okay, so in order for us to do that, though, we need to learn how to divide polynomials. So that's what this section is going to deal with. In this section, hopefully you guys remember, this is probably something that people remember from high school, long division and synthetic division. Okay, so those are the two methods that we're going to cover. I'm not going to give you something overly massive to divide here, just to get you guys sort of like used to it. That's it, just to know what the motions are, okay? So the first one that we're going to cover is long division, okay? Long division will always work, assuming that you do it right, okay? But it will take you the longest to complete. It'll be the longest one to complete, okay? So to start, what I want to do, okay, is this. Before we do the actual example, right, I want to run through basically something that you saw in grade school, probably like third grade, right? So let's say, right, I wanted 100 and, look at me go, 175 divided by 7. Hopefully you guys remember something like this, right? Okay, we're going to divide this out, okay? And what we're going to do is we're going to see sort of like the relationship when we do the actual polynomial stuff, okay? So hopefully you guys remember, right? It's supposed to go like this, right? 7 goes into 1, not enough times. So instead of doing one number, we do two numbers. All right. So 7 goes into 17, if you guys remember, 2 times, right? And the reason why is it's because it's 7 times 2, that's 14. That's as high as we can go without going over, right? So after this, we have to switch the sign. We have to do a minus, okay? This is going to be 3. Yeah? And then what happens afterwards, I want to use a green marker here. The 5 automatically drops, so we get 35. 7 goes into 35 a couple times, right? I believe it goes in 5 times, so 7 times 5, 35. And then we get 0. Yes? Okay, let me do one more. Yeah? Okay, same thing. 7 divided by 178. Okay, I know, it's just three more, but let's go through the motions, right? So 7 goes into 17 14 times, right? So, sorry, 7 goes into 17 two times for 14. So this is going to be switch the sign. That's still 3, but now we get to do this, right? This drops, and I got left with 8. That's still 5 times, right? 35, 3. Okay, so I want to see, I want you guys to notice something, right? In this one, in the first one that we did, whoa, in the first one that we did, the remainder was 0. Okay, and that's because 7 goes into 175 exactly 25 times, right? No remainder. And over here, we get left with a remainder of 3, right? This meant that it did not go in the entire 25 times, right? It went in 25 times and a little over. It went 3 over the 7, right? All right, so let me grab these, and what I'm going to do is I'm just going to move them over here to the side just so we don't lose them. Okay, so we get the motion. Hopefully you guys sort of caught the motion here, right? That it's got to be something like this. We have to put the number there, and then there's a subtraction that needs to happen, right? So same thing here, right? How big does that go into there? And then we have to do a subtraction. We get that, okay? So it turns out that the motions for long division using polynomials is still the same. So this is what I'm going to do, okay? I'm going to write it out the same way. I want 2x cubed minus 3x squared plus 4x plus 5. That right there, x plus 2. I want to divide this big, huge polynomial by this monomial. Okay, so here goes the motions, all right? X goes into 2x cubed. It goes in 2x squared times, okay? So if the way that I would like people to remember it, or that people usually remember it, right, is this times this is equal to that thing, okay? Okay, so this times x is my 2x cubed here. Okay, now I got to do the next thing over where I have to multiply this and this. Okay, and that is going to be, so 2x squared times 2, that's positive 4x squared. All right, if you remember from over here, right, here's where, remember we had a 17 minus a 14, right? We had to switch the sign. We have to do that exact same thing here. So I'm going to do it in red. It's going to be minus and minus now. Okay, this cancels out, leaves me with 0. So now I have negative 3x squared minus 4x squared, right? So now this is minus 7x squared. Okay, and just like before, over here, in this one, we had to bring down the 8, and in this one, we had to bring down the 5, right? Same thing happens here. We're going to have to bring down the 4x that's here, plus 4x. Okay? All right, and at this point, it's rinse and repeat. X goes into minus 7x how many times? Minus 7x. So basically saying, right, I did it in the wrong order because I didn't want the highlighting to go with it. Yeah, minus 7x. So basically saying, right, this times this is equal to that. Minus 7x squared. Okay, now we got to do the other thing. This times this. Okay, that produces minus 14x. Okay, here we're at the switching of the signs again, right? So I have to make this positive, positive. That cancels this out. Here's 0, so 14 plus 4, that is 18x. And here we go again. We have to drop the plus 5. Okay, here we go one more time. So something times x has to be 18x. So you guys see what's going to go in there. That's going to be a positive 18. 18x. 18 times 2. That is going to be a positive 36, right? We're at the step where we have to switch the sign. So minus 0 there. Okay. And we get left with negative 31 at the bottom. Okay. So what the heck did we do? We did this. I'm going to write it down here. Okay. 2x cubed minus 3x squared plus 4x plus 5 is equal to, right, the two things that we have to multiply together, these two, right, x plus 2, 2x squared minus 7x plus 18, right, minus 31. Okay, so what I want everybody to take a look at is this now, and I'm going to erase this up here and right here. I'm just going to put the 25s back without highlighting, right? Okay. All three of these bits are the same. So when we did this, it's the same thing as this, which is the same thing as this and this, right? This ended up being here, right? And just like before, right? This right here is my remainder at the end, right? Which is the same remainder from here and here. Okay, and I forgot to highlight the green. There we go. 25. Okay, it's the same process. It's just a little bit more convoluted. There's a couple more steps that we need to take care of. Okay. Okay, so I rewrote it down below like this, right? The thing that we are, the whole multiplication, if we end up undoing it all, right? That's what we call our dividend. We call this the divisor, okay? And this is the quotient, and like I said before, this is the remainder, right? Another way we can write this, right, is this. We can do 2x squared minus 7x plus 18, right? That is the same thing, right, as my 2x cubed minus 3x squared plus 4x plus 5. We were dividing this, right, by x plus 2, right, minus 31 over x plus 2. Basically saying if you do this division, right, if you do this division, it is going to be, if you do this division and then subtract 31, the remainder amount, right, we should get that bit right there, okay? So, question for everybody, right? Can there be times where there is no remainder? So in this case, you guys saw, we had a remainder of negative 31, right? What happens if there's no remainder? Hopefully you guys are thinking to yourselves, right? That means it divided nicely, right? So if we go back up here and we look at this one that had no remainder, right? We found out that 7 goes into 175 25 times with no remainder, right? That meant that 7 actually divides cleanly, without remainder, into 175. Right? So same thing happens here, right? So yes, we can. And that means no remainder, right? So divides cleanly, basically, right? Okay. A big note, we haven't had this happen yet. And I think I might put an example up when we move on to synthetic division, but we'll get there. Okay. If there is no specific term for a particular power, right, you still have to write it in. So you have to do 0x squared if there's no squared term. Okay. If a power jumps, right, if your polynomial jumps from one power to another power, so if it goes from something to the third to just x, there's a squared term that's missing, you have to write it in. You have to write it in. Okay, I'll give you guys some examples of that once we get to synthetic division, because that's where we're gonna see it better used, best used. Okay, let me do one more example. This one. Okay, so setup is still the same. So I need to do 5x squared plus 3x minus 2, and I want to do the division by x plus 1. I'm going to move it down a little bit so I get more room. There we go. Okay, so x goes into 5x squared how many times? 5x times. So it's going to be 5x squared plus 5x. We're at the step where we have to switch the sign, so minus minus. Okay, this is going to be 0. 3x minus 5x, that's going to be minus 2x. And like we did before, that drops. Minus 2. Okay. X goes into minus 2x minus 2 times, right? So this times this is this. So we have minus 2x here, and then it's going to be minus 2 times 1 minus 2. We're at the step where we have to switch all the signs. So plus and plus. This is 0, so this is 0. Right? Okay, so then this means that we have this. 5x squared plus 3x minus 2 is the same thing as x plus 1 times 5x minus 2. And there's no remainder. You guys see that? So this divided cleanly. There is no remainder. So a nice division through. Okay? Which is nice because now, if you take a look at this, right? You guys see this, the original? This told us very little, right? But now we have it this way. This is telling us what the x-intercepts are. So if you do the break it up, right? X plus 1 is equal to 0. 5x minus 2 is equal to 0. X is equal to negative 1. X is equal to 2/5. Bam, bam. So automatically, looking at this now, right? We know that one of our x-intercepts is going to be minus 1 comma 0. And the other one's going to be 2/5 comma 0. So what we just did, right, is we found the x-intercepts without having to graph them. It's a kind of a tedious process, right? But it is possible. Yeah? Okay. So what comes up next? I have you guys practicing some long division with your groups. Okay. We'll do these in class. Let me move on now to synthetic division. This is the one that people are like, oh, thank goodness. Oh, thank goodness. There's something simpler, right? Okay. So synthetic division is the quicker method, okay? It tends to be much faster, okay? However, it is restricted to monomial terms. So basically something like this, 2x minus 3, x minus or plus 3, x minus 1. So you have to have them like this in particular, okay? Long division, you can divide by whatever you want. So this number over here, this thing over here, can be whatever it wants to be, okay, for long division. But like I said, this one's the one that takes forever. Synthetic division is much faster, but it's only restricted to these. It's only restricted to these kind of terms right here. Okay, so now, how does synthetic division work? Okay, so for synthetic division, okay, what I'm going to do is I'm going to find the zero of what I want to factor by. So for example, if I want if I want to divide this by x minus 3, what I'm going to do is this, x minus 3 equals 0, so x is equal to 3. This is the number that I need to use. Okay, so here's the setup, and this is how I do it. If you remember how to do any of these from high school, okay, and it makes sense to you to do it that way, by all means, do it. Okay, I like doing it this way though. Okay, I put the 3 in the little box, and then I grab every one of the coefficients up front. Okay, so let me actually move that down a little bit so I can have a little bit more space right there. Okay, 5 minus 3 minus 36. Okay, and then I like to put my line down here. Okay, so now, automatically, right, the 5 drops. Okay, here we go. I'm going to multiply those two. So the 3 here times 5, that is going to be 15. That goes there. Hopefully you guys see the, right? Okay, and then I want to do this subtraction. Okay, 3 minus 3 plus 15, 12. And at this point, it is going to be rinse and repeat. So I'm going to do this multiplication, 3 times 12, that is minus 36, or sorry, positive 36. And then I'm going to add these. And if you take a look, you have a minus 36, positive 36, that is 0. Okay, what this tells you is this, that 5x squared minus 3x minus 36 is the same thing as x minus 3 times 5x plus 12. And this right here is the no remainder. So this divided nicely. This divided cleanly. You guys see how much faster this is? Okay. All right. Let's move down one. Let's do one more. Okay. So I want to divide it by x plus 2. X plus 2 is equal to 0. X is equal to minus 2. So that's the number that's going to go in my box. So minus 2 goes in the box. Coefficients, 4, 10, minus 6, minus 20, and then my line, bam. Okay. So automatically, my 4 drops. Okay. Negative 2 times 4, that is a minus 8. Okay. 10 minus 8, that is 2. Rinse and repeat. Minus 2 times 2, that is a minus 4. Minus 6 minus 4, that is a minus 10. Okay, minus 2 times a minus 10, that's a positive 20. 0. So this tells me that this division was actually nice. It was whole, right? There's no remainder. 4x cubed plus 10x squared minus 6x minus 20. So the original is equal to x plus 2 times 4x squared plus 2x minus 10. And hopefully you guys see, okay, that each one of these coefficients, so the 4, the minus, or the positive 2 minus 10, are the 4, positive 2, minus 10 that are right there. And that's it. All right, I've got some problems for you guys to practice in class. We'll do these, like I said, in class. And then after that, it's lecture questions. If you have any questions on how the process goes, of course, we're going to go through it in the class. But if you have any questions on how these go, feel free to ask me during class or come to the office hours in the Math Tutoring Center. Cool. Besides that, happy studying.